Hello, hello, hello. Welcome, everyone. Welcome to episode 61 of BIM After Dark Live. Thank you guys for joining me. My name is Jeff, also known as the Revit Kid. This is a weekly live stream where we talk about Revit, BIM, and all kinds of adjacent software and technology. Thank you again for tuning in live. If you're looking at the replay, thanks for joining the replay. Make sure you subscribe to the channel here on YouTube. Hit the notification bell so you know when we go live. Again, trying to keep it consistent this go around, so it's Thursday nights at 9 p.m. Eastern time. So again, thanks for you joining us all across the world. Today we're actually going to talk about an interesting topic. We're going to talk about structural modeling in Revit. Those of you who follow me for the many years know that I am an architect, so my content usually tends to veer towards the architecture side of things. I recognize that, and I like to bring on folks who maybe use other flavors of Revit and other flavors of the AC industry. So I've got a great guest, Marcello, and I'm sure you guys remember him from previous episodes, but he's going to show some of his top, I said 10-ish, but we could go 5, 10, doesn't matter. It's going to be awesome stuff, I'm sure, as far as structural modeling and Revit are concerned. So before we jump into that, of course, we do need to mention, let me roll down our music here. We do need to mention our title sponsor. I introduced this sponsor last week, and I'm super excited to continue telling you about this company. And so I'm going to roll the clip real quick. So Polycam is our new title sponsor. If you guys aren't familiar with Polycam, I'm extremely excited to tell you about Polycam. And apparently you're getting an echo. I apologize, guys, but extremely excited to tell you about Polycam. It is an iPhone and iPad app, and it actually uses LiDAR to do quick scans. And you saw from the quick video I showed there, you can bring those scans into Revit. There's different ways to bring it in. So feel free to check them out. They've got different formats of exporting. It's really awesome. I've been using it for over a year, and I'm super excited for them to partner with us. So thank you, Polycam. If you're interested, head on over to polycam.bimafterdark.com or hit the QR code here on the screen on your device and download it for free. The only thing you pay for in the premium subscription is different export options. So thank you, Polycam, for sponsoring this show, and I'm super excited to tell you guys about it. I've got more videos coming up, and I'm also going to be doing some work with them to help show you guys how to use Polycam. But it's a really awesome tool, basically iPhone to BIM. I mean, it's really awesome. So, okay, looks like scoured. The sound is good for you, so it might have been a personal problem. Welcome to all the live guys, the live streamers and chatters here. I want to remind everyone that this is live, and I will be checking out the chat. And as Marcello and I are going through our content, we are going to be keeping an eye on the chat. And if you have questions, do not hesitate to ask. So without further ado, you've waited long enough, Marcello. And so I'm going to bring you in, Marcello Sgambelluri. Welcome to the show again. You are
Hey,
now
Jeff, how you doing?
live, and people can hear and see you.
Okay. Can you hear me and see me okay?
I can hear and see you okay. I think it was a little loud at first. I turned it down, so sorry anyone who might have blown out. That wasn't your fault. That was my fault, Marcel.
Oh, okay, no problem.
Welcome again to the show, man. Thanks for coming on.
Hey, thanks for having me. I really appreciate it. Anytime you can invite me on and I can talk about structure,
Yeah.
I'm excited. Yeah, I don't honestly get to talk about this particular topic very often.
Yeah. Well, and I'm excited to have you on. So, trying to think of who I would want to talk about structural, and then, your name always comes up when people think about elephants and Dynamo and Grasshopper and all these crazy and Star Wars things in Revit. But I think a lot of people forget that you are a structural engineer, and so on a day by day basis, you may not be modeling a elephant in Revit. Although I don't know, maybe you do it every day. I don't know.
Quite often.
So maybe for folks who haven't seen, and I will post links to all of your previous episodes. Marcello has come on numerous times. You were actually you and Paul Aubin were the first official guests of this show, which at the time wasn't a show. It was more of just a happy hour during the first week or two of COVID-19 quarantine that ended up turning into a weekly show that turned into what you see today. So I don't think it was called episode 1, but it was actually episode 1. And so you were on that show. You came on to talk about Grasshopper Oh no, was it? Yeah, it was Grasshopper. And then you also came on to talk about your book. So there's a lot of great content. And so I'll link to all those. But maybe for those people who don't know who you are, and especially when it comes to your expertise in structure, maybe give them a quick bio on yourself.
Oh, sure.
Doesn't have to be super formal, just a quick bio.
Sure. Yeah. Hello. Yeah. Thanks for having me back. Like Jeff said, my name is Marcello. I am a licensed structural engineer in the state of California. I started working in the industry 23 years ago. Starting December would be 23 years ago. And I work for a firm called John A. Martin and Associates. We're a structural firm in Los Angeles. And so we do a lot of large structure. So that's kind of a tiny portion of what I do for the industry. A big part of what I do too is I try to find new software, find new tech for AEC and try to push it to its limits and basically tell the industry so we can just make it a better place. My current title is Director of Advanced Technology. So I deal with a lot of just kind of forward thinking, what new tools are out there, how can we implement them as well. So, and recently I wrote a book and it is out. It's the Dynamo and Grasshopper for Revit cheat sheet reference manual. So Jeff, you can leave a link there if anyone wants to check it out.
Awesome. Definitely will. And we did have an entire episode where we sort of walked through some examples and talked about the manual. So I'll also link to that if anyone's super interested. Awesome book, cool layout. And I've got it actually back there on that shelf right there. So I don't think they can see the shelf right now, but it's back there on the shelf. So awesome. Great. So thanks again for joining. I appreciate it. I'm just going to check. I got a little bit of video lag from you. I just want to make sure it's not on my end. It might be. But
you have a way of checking those things out?
Sort of. No, it's all good. But I need to go full screen again. Okay, awesome. So today we are going to be talking about structural and Revit. And so as far as before we actually talk into some live demo and move into that piece of the show, I did want to sort of dig into your experience and your history as far as the structural modeling is concerned. And I'm curious as well to sort of get an understanding. So obviously, as I mentioned, you've done a lot of wild things, pushing Revit to the nth degree. And I'm curious on the structural side of things. How often are you doing projects that maybe are also pushing the structural side of how you use Revit?
Constantly. That's one of my charges or many hats I wear. So that's when I'm usually pulled into a production, is when the job is overly complicated, that either needs a lot of new technology or is just so complex the geometry needs a lot of special attention. So examples like the LAX terminal expansion, large swooping roofs to 250 square foot radii by. Work with the architect Frank Geary Partners. We recently just finished his residence in Playa del Rey. We also, quite a while ago, I did the Walt Disney Concert Hall as well. And then let's see, more freeform recently. Just things like that. But not only is it the forms, but it's also kind of the way you attack the problem. And I look at modeling structure in Revit a lot differently and very unconventionally than a lot of structure modelers do. So maybe we can do some live demos of some things that I've done, just to kind of get anyone who wants to model structure looking at it just a little bit differently.
Yeah, for sure. And I think that's a great way to move. So before we jump into that, I am going to we are going to take a quick content break, and anyone who's followed the show knows that there's a new segment sponsored by Enscape, and that is called the Big Bad BIM Tip of the Week. So we do want to jump into that real quick. And this segment, for those of you not familiar with it, again, brought to you by Enscape. So thank you, Enscape, for sponsoring this segment. But this segment is essentially tips from you, the viewers. And so if you have your favorite Revit tip, shoot it out. Shoot me an email. Let me know. And if I choose your tip to show here live in the show, I'm going to send you a nice free t-shirt. And so that's what we'll do today. This tip is a pretty neat one. It's a simple one, but it's one of those ones that I think is extremely valuable to lots of folks. And I'm sorry, Marcello, you can't actually see my screen, but I think you can imagine while I'm doing this. This tip is actually from a viewer named Paul. Paul, I'm sorry, I forgot where you're from, but if you see this, I'm sure you'll recognize it, and you can shoot me an email and tell me that you saw my tip. So this tip is actually, I kind of added a little bit to it, and so Paul's tip had to do with the options bar, and so my tip on top of that tip is for those of you not familiar with the options bar to get familiar with it and realize it's there. And so what is the options bar? So I'm in a model right now. This is actually a structural model, believe it or not, and if I go to do something like a move, a copy, an array, anything, so I'm going to do MM on my keyboard for a mirror, you'll notice the options bar, which is the nice green or gray, depending on what you're doing, bar in between your ribbon and your view. And there's usually stuff that you can do on there. And so notice it says copy, right? And so my first tip is really just to pay attention to that bar, realize it exists, and realize the power that it has. But the tip from Paul is actually, if you are doing something like a mirror, if you press Control on your keyboard and you hold it, it'll actually uncheck or check the copy, which is pretty cool. So that's for mirror, but if you go to actually copy an object or move an object, you have a couple options. You have constrain, disjoin, and multiple. And so if I hold Control and let go of it, you'll notice it's actually flipping between disjoin and constrain. But if I press Shift, it's actually unchecking or checking constrain. So pretty cool tip. So 2 tips in there, I guess. The first tip is pay attention and get to know the options bar. I think that is going to be big for everyone. I'm sorry, I just lost your face, Marcello. I apologize. Let me.
Okay. I'm still here.
I know you're still here, but I lost you. Let me. Oh, there's Zoom. Silly. All right. So everyone probably just saw like the cheek of my son on my desktop background. So the tip there is pay attention to that options bar. There's a lot of great things on it, first and foremost, and then using Control and Shift while you're in the middle of an action, you'll see is a quick way to uncheck and check things. And so I use it all the time. It's super powerful, especially like when you're mirroring and copying. But Paul, thank you for the tip. Awesome tip. I hope it helps some of you guys out there. And again, thank you for Enscape for sponsoring that tip. All right. Pretty cool. I know you didn't see it, Marcello, but I know you probably imagined what I was doing, right?
I used my imagination.
Awesome. It looks like a couple of folks didn't know that tip, which is fantastic. So always great. Some ACAD said, is that called the contextual menu? Maybe. I will tell you, and anyone who's followed my content knows that I am not a stickler for the exact terms on things, but I think it's called the options bar. I don't know. Context menu, options bar. I showed you what it was. It was the thing in the middle. Maybe it's both. I don't know, though. Is it? What do you call that, Marcello? The bar in the middle. You call it options or contextual menu?
Options bar. Yeah.
Options bar? Okay.
Yeah.
Awesome. All right. So yeah, and I want to remind everyone, again, if you're here live tonight, right now, feel free to ask questions in the chat, and I will keep an eye on it as we're going through our conversation and butt in where it makes sense during Marcello's live demo. So all of that being said, welcome back, Marcello.
Thank you.
See, no one can see your screen yet, but Marcello's doing some cool things on his screen. So I don't know, Marcello, where we were kind of talking about how how
where you want to go.
Yeah, where you want to go. How the crazy stuff that you do would be considered maybe non-structural, how that relates to what maybe you would do structural. And I'm curious to see how your mind. I mean, one of the things, and I'll give you credit to this, that I've always loved about learning from you at conferences and whatnot is you always have a different way of looking at things and approaching a problem. And so I'm curious to what you just said before, some of the ways that you may think differently than your typical structural modeling, engineer in Revit and approach a problem structurally, because I'm sure it's going to be fascinating.
Well,
so maybe we'll start there. Let's start there. Let's talk about how does Marcello approach a structural problem, and what kind of I can see you've got some demo stuff, and so maybe we'll jump into that if you're ready for that.
Yeah, I am. Sure. You want to? I guess
let's do it, man.
Share my screen.
Yeah.
Okay.
Yep. We all see you and the screen now.
Okay, awesome. Okay, so that's a good question. What I've learned when I've taught a lot of classes on modeling in Revit is that you're not just limited to the tools in front of you. So if you were needing to model roof framing roof structural framing, structural walls, things like that. You don't just have to contain yourself to the structure tab and the tools that are here, like beams, walls, columns, floors. I've learned that Revit is an extremely complex, robust program that has lots of modeling tools. And so if you limit yourself to the structure tab, then you're really not, you're letting some of the best things in life pass you by for your, if you're a structural modeler. Or, Jeff, even if you're not a structural modeler, I would argue if you're an architecture or even an MEP, you need to be very seriously ingrained in understanding the structure within your Revit model, because if you're an MEP, you're going to need to know how to move around it. If you're an architect, you definitely need to know what's going on with it. And so I think structure really needs to touch every designer's lives. And then you could have the same argument on the construction side. So this is very important. So I think what tends to happen is you hear, well, we're going to talk about structure, and then some people tune out. Well, no, actually, you should be paying more attention, because even if you never modeled structure in a Revit model ever, you need to have some knowledge so that you could be double checking your structural engineers and your structural subconsultants and the work they're doing.
Yeah.
Case in point, maybe we should just move ahead to a common misconception, which is a lot of times when you see structural framing, a lot of time when you see structural framing like this, you would see like this is just like a simple structure roof. I actually made this up, but just to drive the point home.
I was trying to figure out what kind of building that was. I don't know. I'm trying to figure out the space underneath it. You made it up. Got it.
Yeah, I did. I made it up. Just some framing, slope framing, some flat framing. It could be a roof, whatever. Okay. You may look at this and say it looks good. What tends to happen is you tend to see, now that, and it's been a while since we all been one box where Revit, structure, MEP, architecture are all one now, you sometimes tend to see this left on, which is the analytical model. Yeah, so you see here, you see the analytical. Can you see it? It's kind of thin. Maybe I go.
Yep, I can see it.
There it is. Yeah, and what the first thing that's very typical, Jeff, too, back me up on this, is you're like, nah, I got to turn off the analytical. Does anyone do that?
Oh yeah.
Wait, you're asking to start?
Sorry. Yeah, the video might be asking you to start again. Just click start.
Do I say start?
Yeah. Sorry about that. That's your webcam. I was trying to. There we go.
Can you still see me and hear me and work it?
It's perfect. Yeah, it was perfect. It actually killed the lag. I was still getting the video lag, so I think we're good now.
Okay.
You're nice and smooth now.
Any of the listeners chiming in on this? Does anyone do this? Like, take the analytical and turn it off immediately because you don't want to bother with it? It's common, right?
Oh yeah, I do it. I do it every time.
Okay, actually, my comment is that's the last thing you should do. And the reason that's the last thing you should do, you say, well, why? I'm not going to deal with structural analysis and the structural analysis model in another sub. Well, okay, yeah, fine. Maybe you never will. But there's a lot of hidden gems in the analytical model, particularly around quality control and a quick look. So if we look at this framing, right, Revit tends to actually drop the beams back, supporting beams back from the supporting beams. So these are the girders, these are the supporting beams, they tend to kick back. So you can't really see work lines. If you turn on the analytical lights, it actually gives you a good telltale sign of the actual work points of these beams now. And so you may look at this and say, okay, it actually looks pretty good. Now, if you were to take one more step and turn off the physical model, then all of a sudden more things jump out at you. Like I can look at this with my eye and all of a sudden, bang, right there, I can see there's already an issue. Now, it's only because I'm using the analytical line because I can see the center points, center lines, and work lines. And then I can turn the physical model back on. And then all of a sudden I'm looking like, okay, you know what? There's actually a problem. But when I look at it like this with it up, I don't have a problem.
Right.
So the first thing is, okay, you might think, well, what's the big issue? This is only so far apart. But actually, did the structural engineer really intend for these to be offset like that? I mean, okay, maybe, but probably not. So even as an MEP or architect, if you see something like this, you need to bring it up. Like, hey, listen, we saw some of these issues, maybe even show them how to turn on the analytical and take a look at it. Right. So it's a good telltale quick sign. So
And I will
that's,
tell you that about 5 people said that they do it always. They turn the analytical off. There's
yay.
probably about a 9 second delay between what they're seeing and what we're saying. But there was about five or
Okay.
six people that said yes, we turn
And
off the analytical. I could tell you, and I'm one of those. That's probably what I do first too, especially if I'm just using the model. It's like get
oh,
those
I'm
lines out of
cheering.
my way.
You mean they turn it off? Okay, I was
Yes,
cheering
turn
that
it off.
they
I'm
turn it
sorry,
off.
turn it
Okay.
off. Turn it
Well,
off.
let's
Turn
think
it off.
about the
Which means you
reciprocal
were
of
right,
that.
so you can still cheer.
Let's think about turning it on and using it as a quick quality control.
Got
Just
it.
really quick. Whether you modeled it yourself, whether you're in a structure office, someone modeled it, you want to look at it, whether you're an architect, like MEP, contractor, you can turn it on, take a look, awesome tactile sign. Now, there's actually a lot more you can do with the analytical model, and people don't know this. Let's not have a conversation about structural analysis. Nothing to do with structural analysis. Right? We can look at this again and you could say, okay, actually, you know what? I want to actually move this beam from here to there. Right. So there's a few tools you actually have in the analytical space that a lot of people don't realize. So if you were to actually click on the analytical line, you have the ability to do an analytical adjust. Now the analytical, let's call it the world, works a lot like the smart points in adaptive components. So you could actually take this endpoint and say, you know what? You're not supposed to be there. You're actually supposed to be here. Okay. Now, structural engineers may have a problem with you adjusting their analytical model. Okay, well then let them do it or show them how to do it. Or they may just say, I don't care. I'm not using it for analysis. You go ahead and move the structural analysis line, have at it. Okay. So you can do that. And then you can say, you can click finish. My finish button is on the other screen. I don't know why. And then you can do that. But then see, this beam is still not lined up, right? Okay. So right now, if you wanted to do a 3D align with this analytical line and this beam, you actually don't have the ability to do that. So if I take this and click here, there's nowhere to click on this beam other than like the hard edges. So when I first thought of this problem, I thought, you know what, why isn't there a center line on a beam family? And I was like, there really should be. And then it hit me. I'm like, why are you complaining, Marcello? Why don't you just make one? So if you actually take your structural analysis, your structural beams, right? And then if you just go to a plan view and then you take a model line, right? And you can put a toggle on it to turn visibility on and off, right? And then if you align it now with the center like that, you can snap it. And then here we're snapping, and then we're here and we're snapping, right? And then I go back to the 3D view. Do you see there's actually a line there? Now I could probably put in a visibility parameter, turn on and off, whatever. Okay, I'm gonna load this right back into where I was, which I think would be there. And then now look, I have actually a center line that I can see right there. And guess what? When I align it, now I have a center line, boom, I can align to. So I just aligned that beam using the analytical adjust world, as well as putting in my own beam. And then you can unload them or turn them off with visibility, whatever. But you can leave them on too, if you want to, the center lines. So when you turn off the analytical, you can actually have a bit more freedom here. So you can see now beams will actually have center lines on them. So you can use that as your quality control if you want to as well. Okay, so that's just kind of another way of looking at structural beams. Now, if you're an architect and you get a structural model and the architect says, don't touch my structural beams, okay, fine. Maybe you can show them how to do it.
Right. So I'm curious though, because I usually turn them off. I don't mess with the analytical beams or the analytical lines pretty much at all. So when you're moving that, because that analytical element was being built when you put the beams in, right? That's how it was created. But when you moved it, it was disassociating itself from the beam?
It's not disassociating itself from the beam. That's the nature of the
okay.
That's the nature of an analytical model, is that if you build a physical model, the analytical line is always built with it. However, in the analytical adjust world, you have the ability to shift and move it around relative to the beam. They are, quote unquote, through the API still associated, but you have the ability to do that. Now, why do you do that? Because sometimes in structural analysis world, you need things to be idealized and lined up and continuous when in fact, maybe a beam is slightly down 2 or 3 inches, but for an analytical, for the math and being things consistent and your finite element asphalt using, you need the nodes to kind of line up. So they're not disassociated, quote unquote. They're just not physically matching the exact location of the beam, which from a structural engineering standpoint is perfectly okay. So I'm going to cancel that.
Steph asked a good question. I think that's right along lines of this. So she's an architect, and
Okay.
when she's linking in the structural models, what options are there for using this the visibility is there a way to turn on the analytical and QA QCing the same process through a link instead of being in the structural model?
Good question. Okay, the good question. Okay, what I just showed you with quote unquote moving the analytical line and physically moving the beam would not be possible in a link, but you would be able to see the analytical model through the link. You just would have to turn it in through your visibility graphics within the link, and then they would show up. So if you wanted to make an adjustment, I suppose you can copy and paste the beam out, or call up the structural engineer and tell them how much you were admiring their model, and you just happen to notice a tiny discrepancy after after you've taken screenshots and pinned it up onto your home office.
Right. Yeah. So that was
you got to be gentle sometimes when you mention things, and it might not, and you see things like that, little discrepancies. Sometimes it's better to get those handled where you don't email the person who modeled it, their boss, the principal, and everyone else like that. Sometimes it's good just to handle those things kind of locally. There tends to be better results.
For sure. Yeah, that was a great question, Steph. And so I think her question was definitely more along the lines of the visibility. And so you would handle analytical elements the same as you would anything through a link, I believe, right? It would be through visibility graphics. So check that out. And I think she also was asking about the model lines and the families. So that would depend on how they built the family. What Marcello was saying. If that was through a link, for example, and you didn't turn off that visibility, I guess now you're how could someone turn it off? I guess.
You wouldn't be able to. You wouldn't be able to. This was if the beam is natively in your file. If it's through a link file, well, you can't edit a linked file anyway. You can only look, don't touch on a linked file. So you just have all those. You would just have all those limitations. I think at this point, what you would do if you have a hard rule about not modifying structure that's a linked model, then at that point you could turn on analytical, see there's an issue, then talk with the structural engineer or the author of that 3D structural model and show them how to make the adjustment, like I just showed you with the analytical, just putting in the beam, and they may appreciate that.
Anthony had a good question. He said, is that different from structural framing location line subcategory? So maybe he's talking about the center line that you're talking about, or the model line you drew.
It is technically different. There is a center line subcategory, but it's not always visible. And so when I built the line, I just had the ability to control the visibility, like at the project level, easy peasy. So it was a lot easier to work with. There are other ways to do what I just did with the align, but I found that to be the best way.
Yeah, and I think
it also depends on
in 3D too. You won't the subcategory. I don't think you can, like you were trying to use an align in 3D, right? And so even if it had the subcategory, even if it was like a reference plane, I just don't think you'd be able to select it. And that was your point, is if you're trying to use an align in 3D, I don't think you can even see it, right? Depending on how it was created.
I've never have, but I haven't really vetted that out entirely. So awesome. I mean, this works for me, and it's right there. And so another thing I do is I model my structure, my roof framing that happens to be sloped, not my flat horizontal framing that's sloped. I tend to model it all in 3D, just because I can really keep control of it. And so so if I can take this just to the next level, which is what we did there is we just realized that there is a very powerful thing going on. And this is the revelation, the big aha moment that I had, which was I spent a lot of time trying to move this beam. And so now that I built this line in the analytical, now that I built this line, which represents the center work line of the beam, and I loaded in the family, that's so like 3 minutes ago. So what I realized when I was doing this was actually there's a bigger picture here. So what I did actually was I was like, I don't want to go through those 4 steps. So I actually hid the beam like this, and I get goosebumps every time I do this. And I was like, I already have the line where I want because they have the smart points. Then I just took another beam and I actually in 3D snap, and I just snapped it down in that spot. And then I was like, whoa, wait a minute. What did I just do? Okay, now I'm using an analytical line, smart 2-point line, 2 points to place a beam. Okay, but it still belongs to another beam. Okay, then it hit me. Oh, what if instead of doing that, what if now I can lay out structural framing instead of with the analytical line, although turn on the analytical line, see if it's right. But I thought, you know what this really is? If you look like at a 2-point smart, and I was thinking, let's just look at mass. If you have a mass that just has a line and 2 points at the end, right? These points are actually very smart. So if you actually were to do an in-place mass, I'm not saying you have to, right? Then you actually get the smartness of the point. So instead of just snapping at the ends and the midpoint, you can actually snap it somewhere kind of in between. You know, like if you wanted to, you can actually control this, and you could actually hit, say, when you look at this, you could actually hit like the quarter point if you put in 0.25, because that's the actual relative length along this beam. Or you can turn it into an actual length. This becomes even more important when you do this, but then it's like on something even more complicated, like from here, and then let's say you needed to go along the arc length, say 5 feet across. Well, then you can actually take that, and then you can change this to a to a segment length. I guess we go from the beginning to the end, and then you can go over, say, 5 feet, and then it'll hit it right on. And then you can take your structural beam that I did earlier. You can finish that. Take your structural beam, and then do a 3D snap on it, and then pow, it just drops it right in place. So you now have brought that up. Now, I've talked to people who have not done this method, and they want to actually take a beam from, say, this center line to here. And I've asked them, what do you do? And they say, oh, okay, what I do is I actually go and plan, and I cut a section, and then I go look in the section, and then I very gingerly, carefully click on the edge as close as I can, because I can't really snap to it.
Right.
And then I do that. And then when I do the next one, I cut another section, and another one told me actually what I do is I take this beam and I export it out to AutoCAD. I run an array, reload it in, and now I have the segments, and then I snap. I'm like, wait, why we don't just use something smart like a mass? And I was like, wait, why use a mass? I was like, let's take it one step further. If we don't use a mass, but we use something else, right? Which is even smarter, is if we use an adaptive component. An adaptive component, actually, if we start a new family, and then we go to generic model adaptive, we can build a line with 2 points. So also all we do, I'll show you how to make one. We just take a line with 2 points, 1, 2, doesn't matter where. You take the 2 endpoints, and then you make them adaptive, which means now point 1 will ask you where to host, point 2 will ask you where to host, okay? I already have a pre-built one, so I built that one in a few seconds, but I have another pre-built one. And then I thought, okay, if I actually make a 2-point adaptive, maybe of every beam size, then I can just start laying out framing really fast. Now, my little secret is this is how I lay out all my roof framing is. I don't bother with the structural tool. I actually take adaptive components and I lay them out. So like I can go from here to there and there to there. And of course, they're all smart, right? I can even do beams that are in between if there's like an opening, things like that. And then when I'm all done, laying it all out and I'm happy and I'm all happy with the center lines, then I'll come in with my 3D stamping and my beam tool, and then I'll just go snap, 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 and then I'm done. So that's how I usually model my structural framing now with the tip of that. And it all started with that revelation when I was moving that analytical line. I'm like, oh, we've got so many more tools in here that could really help us lay out the structural framing.
So let's unpack that a little bit, because that's pretty awesome. And it makes sense when of course when you explain it, it makes sense. But so I'm curious now. So we're using this, and I'll give folks time because I'm sure there's gonna be questions on this part. But so the nice thing about this too is it's adaptive. So if you were to change that arced beam, all those other beams would update, right? Because they're hosted to the adaptive. The adaptive would update, not the arc.
Yeah.
So my question was going to be: do you leave that line in place, or what do you do now that you've created this structure that seems to be really simple to create, but now the architect changed the roof because that's what we do, and now you have to change your structure?
Okay. Hopefully it's not after DD, because it's pencils down, right, Jeff?
Yeah.
DD, at the end of DD, right?
Pencils down. Yeah.
Okay. Let's first talk about that. So first of all, we realized that, well, this is how I model my framing. So if you want to consider something like this, go for it. If you're not a structural engineer, maybe you should tell the structural engineers you know, who are struggling with modeling framing that either on curves or slopes or whatever, you may want to have that conversation with them, first of all. Okay, so in and of itself, I feel this is really powerful. This is how I do it. Now, when I take it to the next level, which meaning that if I anticipate changes, like for example, if this were to actually physically move, okay, the power is that if there were a change, this line and all its associated adaptive components will quote unquote move and modify. So if, for example, I didn't want this at the quarter point, but I wanted this at the 15% point, I guess, but I wanted it actually at the quarter point, right? Which that one I guess is close to. Boy, Jeff, I almost hit that right on.
You almost hit it right on the money. Yeah, that's pretty
good. then these do not update with it. Okay, so that's just kind of the reality and the world we live in. Now, I'm willing to accept that because, quite honestly, first of all, let me tell you, anything that I do that helps me, I'm already appreciative.
Right.
Like I'm like, thank you. These are gifts, I think, quite honestly. So I complain only very little and very quietly. But if you want to take it to the next level, like Jeff said, and you say, okay, you know what? If I do need to actually place and have that beam move with the line, then we got to ask our friend, and it starts with a D. It's Dynamo. Dynamo can help us track this beam and follow the line. So if you want to, really quick, I can actually manage. I can actually show you a script. I won't build it from scratch, but basically with a few nodes, okay, you can actually have Dynamo say, grab all those adaptive components, place a beam on the adaptive component, and constantly track it. So if it moves, then you move. So here we go. Okay, so open. Here it is. Okay. So here's the script. I won't get too much into it, but we basically pick all the adaptive components. We change them to curves, or we extract the curves. We then take structural framing of a type of a size that we want. And then we basically can run the script right here. Pow. And then it's going to actually place the beams on there at all times. Now I can change this to automatic, let Dynamo run in the background. And now if I want to, I can have a framing party. So actually, anytime I pop this adaptive component down and then I escape it, it's going to drop a beam on it. So I can do that now. And since it's constantly tracking it, if I were to take this and slide it, then the beam will automatically update to it because Dynamo's in the background working. Now, do you have to have Dynamo in there all the time? No, you can have it as like a player and then just run it anytime there's an update. But Dynamo can really help you in that regard. Yeah. Does that answer your question?
Yeah, no, it does. That was great. And I think someone did have a question about, can you align and lock the beams to those adaptive components? And I think that was where I pulled the question from.
Okay, so the answer is no, you really can't. And it's because the structural beam is not that smart, at least when I tried it. It's over 20 years old, that technology. The adaptive component is newer. Right. It's about 13 years old. And Dynamo is the newest, right, which is about 6 years old. So if you combine those three technologies together, then you can accomplish, I think, what Jeff was asking there, which is if there's a change, can you have it move? So that's how that's my little secret for how I actually lay out structural framing all the time now. Yeah.
So in that case, because I was curious, you haven't even used the word beam system yet, and so that's why I was interested.
I have not used the word beam system. No. And you know what you can do. It's a very good point. Is no. And you know what? I'm not going to say don't use beam systems, but for me, my modeling is very efficient. So I don't use beam systems. What I tend to do is I'm just going to do a little whatnot here. So if I had these two lines, however I model them with adaptives or whatever, where are they? Here and here. I'm going to isolate. Whoops. Here, where are they? Here and here. Yeah, and then I'm going to isolate. So what I tend to do if I want to put in beam systems is I'll put them in a slightly different way. I'll use a divided path, and then through there I can control the fixed number and so on. And then from that, I can finish, and then I can turn everything back on. Now, when I go through my adaptive component, let me see if I can find it. Then I got to pick the lines. Hang on.
They're in there. They're in there. I see
they're in there, right? Okay, so I'm actually looking for the divided path line. I'm looking for the maps. Yeah, there they are. Yeah, see, there they are, right?
Mm-hmm.
So what I would do is I would take the adaptive component and I would actually place it on there.
Mm-hmm.
And then I would use a repeater
Mm.
under P, and then it'll actually place the adaptive components that way.
Mm-hmm.
And then that's how I kind of mimic
Mm-hmm.
the BIM system.
Mm.
And then I can parameterize the divided path and so on.
Yep.
That's kind of the divided path method with a hybrid of Dynamo. Did you see how even if I put the divided path within
it's
the
still
family,
made,
it still grabs it?
Dynamo,
which is beautiful.
Yeah.
But you don't even need a divided path. If you wanted to take a line, extract the center line of this beam
mm-hmm.
and
Mm-hmm.
this beam from Dynamo and divide it that way, and you could do that too.
Mm-hmm.
So I tend not to use beam systems, although I think they're really good for laying things out. I'm not harping on it.
That's why I was curious because, I mean, for example, I was just showing that you didn't see the sample yet, but the sample I was doing during the tip of the week is it was cold formed metal framing. I was doing some work for somebody doing cold formed metal framing, and I was. It's interesting because I was thinking about it as you were saying all of this, and what I end up doing is using a beam system for the initial layout, and then there's this awesome button that just says remove beam system,
Yeah.
and then they just become beams, and then you can just do things with them, and the truth is that's kind of how it always ends up is a lot of times I don't end up leaving the beam system in place. I end up blowing it up and just using it, and it's kind of the easy way to lay things out quickly, so I mean it makes sense because now you're giving yourself the flexibility that I created after exploding the beam system once it was made, right?
Yeah, and you bring up a good point. If you're more comfortable using a beam system than exploding it, or if you're more comfortable using the Dynamo hybrid or just Dynamo, it's all up to you. I think it's just a lot of more ammunition.
I think once you start going off plane, right, if not horizontal or vertical, that's where this is super helpful, because with a beam system you've got to have something, a work plane, you got to create it, you got to host to it, and then you got to go from there. This is nice because you can break off plane, like you're showing curves, whatever, it doesn't really matter.
Oh yeah, you bring up a good point. I invite a beam system on this bay, and I'm interested to see what would happen. So
yeah.
But it's all good. Okay, so we talked about okay, so I think we're kind of talking about how to model framing differently. Now a question came in and I saw it, which is, can you make an adaptive as beam so you won't have to build the skeleton? Yes, and that's a good segue to what I want to get into next, which is a lot of times we have like barrel framed roofs, and you need to actually take a structural beam and you need to frame a beam to it, and many of them, but the problem is that the beam needs to be perpendicular to the actual surface. Yeah, and so what tends to happen is you take this and you go to your rotation cross-section value, and you're like, okay, it's 45. Oh, nope. Okay, it's minus 45.
Oh yeah.
Oh, no. It's minus 40. Getting there. Minus 35. Minus 32. Now you may get lucky, minus 30, right? But then you put in another one and you got to play the game over.
Oh yeah.
Okay, so what I do for this type of framing is I use the power of the adaptive component and the repeater. So if I have a surface like this, then I can investigate it a little more. I'll isolate, and then I have the shadow on, so it's giving me that little whatnot, but whatever. Okay. So if you take this surface like this and you actually can divide a surface. And now what some people don't realize is that the divided surface under surface representation actually has nodes at its intersections, and you can turn those on. Now I have already pre-built a structural beam as an adaptive component. So if I look at this beam, it's just a simple 2x4, but it's basically an adaptive component with 2 points, but instead of just a line, it's a line and an actual solid extrusion to represent the dimensions of a 2x4, which is 1.5 by so on, right? And then so if you actually place that on to the smart points, then it will know to orient itself perpendicular to that surface. And then what you can do is then activate your repeater, and then it will place the beams at the orientation perpendicular flange, tangent, web perpendicular to that surface. So you don't necessarily have to play the rotation game.
Oh, yeah.
So this is kind of the manual way of doing it. In the book, I actually show you the Dynamo solution. So, you know, either way, it can kind of get you there.
So in that situation, if I'm using that now to create my model, which is then creating my documents, are you leaving that beam in place? Are you categorizing it as structural framing at a minimum, just to make sure that you know, things are looking and acting the way you want on the documentation side, as well as the sort of, you know, model use side of it?
I used to do that, Jeff, which means that I would take this beam and I would then put it into a category that I was comfortable with. I would edit it as well so it looked correct in my documentation. That was so 2018. What I do now is I have come up with a more elaborate Dynamo script that mimics the adaptive component behavior. So basically the way it works, and it's not in the book. I plan to do a volume 2 on it, which is you basically, when you place the structural beam, then Dynamo will analyze the surface.
Got it.
And then it will then go in and modify the cross-section rotation based on tangent vectors, normal vectors to a plane tangent to where that flange is ideally supposed to be. And then it will then rotate it into place. So that's how I kind of do it now. But yeah,
so then with that, it's placing the actual beam. It's just doing the rotation part for you, but it's using the same logic you're showing here.
Correct.
So if someone's using the adaptive component piece, how would they incorporate, if they wanted the analytical model with it? Would it be using just lines? Would it be placing beams and getting rid of them, or
if you're talking about analytical is only ever exists with the Revit structural beam family. So you'd have to then draw over structural beams if you wanted the actual analytical lines. But if you wanted to, you could get savvy, and I've done this quite often, is you can build the adaptive component family such it's smart enough to actually look like you want it to do in all your documentation. You know, for example, the solid turns off, it just a center line turns on. You know, you make sure that it dimensions correctly. It's hiding when it needs to hide, things like that. So you do have the freedom to do that in adaptive component. It's just a little more work. So I found I did that for many years, and then I finally said, you know what, I'm gonna make a Dynamo script that could do that. And actually, on my blog site, there actually is reference to it. Can I go there really quick? I forgot I actually posted. So before we kind of close the evening out, my blog site's called simplycomplex.org. And if you head over to my blog site on simplycomplex.org, I do actually talk about orienting structural framing perp to surface. And I have the Grasshopper solution. I don't have the Dynamo solution in here, although I am working on an equivalent Dynamo one. I have the Dynamo one, but I didn't expose it. I plan to put it in the volume 2 of the book. So it's basically the logic of taking the planes I talked about and reorienting it. Some more advanced surface analysis to kind of get you there.
Awesome. Great. Okay. Yeah, and I'll put any of the links you mentioned here. So simplycomplex.org.
How about one more before we close out? Can I show the cow?
Of course we can show a cow. What?
We got to show the cow before we go.
It wouldn't be a Marcello presentation without a cow or an at or something. You know, a human head. I don't know. Whatever.
Okay, so we got. Where are you? The cow's in. There's the cow. Okay, so the question is how do we model structure that can follow some complex surfaces? So I actually have the cow here. So what I'm going to do is this was actually built out of the massing environment a long time ago. So I'm going to actually host a wall to this surface. So I'm going to go host, and then so it's actually made up of this one, as well as it's one sweep from the back leg all the way to the nose. And then I guess I'll take that one or this one. I meant to grab this one. I don't know why I couldn't do it earlier. Is it that one? I think it's that one. Yep. So I'm placing a wall by face. So first point is a wall by face can follow a very complex surface. If you can follow a cow, you can probably follow most surfaces as a wall by face. They're actually very, very powerful. So I'm going to then isolate this. Okay. So here's the thing. If I wanted to place a beam along this one right here. I don't know if I have any elevations shown, maybe not. But if you ever look, yeah, if you ever look, that's the back end. But this is kind of cutting through a little bit of the cow. If you wanted to actually place a beam that follows this and you activate your structural beam command, you would need to pick a plane for it to work on, first of all. And then from that point, you would need to select this edge, and you don't have the ability to actually select that edge just because it is not actually, it's not actually quote unquote a physical edge. So what you need to do is you can just take matters into your own hands and make your own edge. So for example, if this is the grid, there's no grid here. If I wanted to do that, then I come back to 3D, right? Oops, not that 3D, this 3D. Come on now, where are you? Here, then I can take a wall and I could just intersect it with the cow wall. Then I could join them. So I can join this with this. Now, the only thing is I'm trying to make an artificial edge at which to pick. Otherwise, you'd be clicking all day in that section and you'd never get the edge.
Right.
So this is what I kind of call the intersection method. Now, if I hide this, I'm not going to, I am going to see it. There it is. See how I made that artificial edge right there on the join? So then all I need to do is take my beam and my pick tool and the size of my beam. And then now that I have a solid edge, just pow. And then I can pick the edge. And now I actually have a beam that's following that crazy surface. Okay. And the trick is just to make your own edge. That's all you need to do. Once you have an edge, you can place a structural beam for it. Now, of course, you have a Dynamo solution to do this as well, where you extract out the surface, do an intersection, bring the curve in, and then place. But this is kind of the non-Dynamo solution. So this is how I'll lay out structure a lot of times. Or actually, I'll place a floor sometimes in here and have the floor follow those crazy edges. You know, like it doesn't have to be a cow, right? I mean, if you're doing a building with some complicated facade, exterior, you got exterior model, you're doing the core and shell, and you need to have your slab edges match that exterior facade, you can use methods like this. It doesn't have to be a beam. It could be like a slab edge, you know, to do this little intersection method. And
I think that the key takeaway there is the edge part. But also at the same time, it's interesting to me because you mentioned before, right? Beams are a 20-year-old technology in Revit. But I will say that they are extremely flexible when it comes to picking edges. And it's surprising to me sometimes how crazy and wonky they will sweep without blowing up. And so that's, in general, that's a good lesson too, is you can pretty much pick any shaped edge and the beam will follow it. I've found some pretty wild things with that, which is pretty cool when you think about it. Because some of these things you might not even be able to make with the sweep if you tried in place.
Yeah, you're right. You're right. It is. I guess it's really rock solid when it's grabbing onto an edge. I found that to be the case. Yeah. Awesome. Yeah. Good point.
Very cool. Joe asked, where can I learn how to make the cow? There's content out there. You've showed it every once in a while here and there. So if you dig deep enough, you'll find it.
Yeah. I taught a class in 2013, 2012 on it's called Secrets Models Revealed, something like that. And I did show how to actually model the cow. That's at Autodesk University. You can see how to do that. Also, my blog site goes over it a little bit, but it's really not that complicated. I mean, it looks complicated, but it's really not. There's just some things you need to be aware of because you're modeling using the massing environment in Revit, which can be a little touchy because it uses Hermite spline formulations, not NURBS. The important part is that as you sweep through profiles, you need to make sure they're continuous and smooth. You can't have anything that's like really wonky. So my profiles for this cow from the back leg all the way to the nose would look like this. If you see my cursor, it'd be like radial lines from here to about here. Then they'd be parallel lines to here. And then as I hit the neck, they would be radial lines again to here. And that's how that profile would look. So if that gives you any guidance on being able to model something complex in Revit, that's kind of the tip and trick there.
Awesome, man. No, this has been fantastic. Is there anything else you wanted to say before you leave? Is there any content that you didn't get to hit? Because we can hit it if you want. I mean, I know
I could go all day.
Fantastic.
I think if we're gonna focus on structure, I think we covered quite a bit.
We did. That was fantastic.
There's a whole nother part of structure that I have taught, which has to do with like game engine technology and visualization. not just modeling and Revit. I think probably the biggest takeaway, if you forget all the picks and clicks I said today, is if you're trying to model something in Revit, whether it's structure or not, don't be limited to reference planes, reference lines. You can use anything you want. In fact, the way we modeled this beam was we used a wall, right? Why did we use a wall? Because it was solid and it was easy to model, and we were able to do an intersect. Yep. So that's why. Why not a reference plane? Because a reference plane wouldn't work. And we usually think of guide geometry as references, but no, guide geometry could be anything. And so that's it. If you want to know, I actually have another little, you know what I do? Sure. I have another little secret. So sometimes when I use this guide geometry, I'm kind of turning things on and off. And someone saw me do this one time, which I didn't really think anything of, but they told me I'm absolutely insane, which is if I hide some of this stuff, a lot of times I'll go to the hide world and I'll model in the hide world. So I'll model in reference lines, reference planes, beams, columns. And then I'll do my intersections, because you have all of your commands still available to you in the hide universe. They just don't show in the show universe. So I'll model in the hide universe, which is actually a very stable place. Then when I'm done, I'll pull out, and then I have done all my guide geometry. And then, I have kind of what I need. So that's kind of a little secret. And honestly, Jeff, that's a tidbit that I'll give you for your show exclusive. First time I've ever said that before. I will admit it. I model in the no-show world. I'm a no-show world modeler.
The pink must drive you a little nuts, though. I don't know. That's a lot of magenta happening there.
It is a lot of magenta, but I've learned to be friendly with the magenta. I'm sure some API aficionados out there, including like John Pearson and others could tell us how to write scripts to change the color in the no-show world.
Awesome. No, that's great.
So maybe that's the next class, no-show world modeling. No-show world. Don't forget.
Awesome. Well, again, Marcel, thanks a lot for doing this. I appreciate it. Folks, welcome. So I'll put all the links to all the information, but I guess the best place to reach out to would be simplycomplex.org, and on Twitter at Marcello. I'll link it there. I'll link all the information there. Any final words before you go?
No, just AEC is an awesome place. It's filled with intelligent, smart individuals like all yourselves. Don't sell yourself short. Keep doing awesome things, and make AEC a better place. And keep up the good work. Awesome. Oh, and if you're wondering, that's my lightsaber collection in the background.
Oh, you know what? They actually can't see it, I don't think, right now. The way
it's cropped. Trimmed it?
Hold on. I'll pull it out right now just so that everyone can see it. I'll even hide my own face live. Making the sausage here. There it is. If you're really interested in it, everyone, we went.
I usually get that as a question. I'm like, why didn't that show up yet? I think because you cropped it, but no, it's all good.
Sorry. We went in pretty deep on that one of the episodes. So I'll find that. Maybe we can pull it out. Thank you, Marcello, again for joining us. Thank you guys for joining us live. If you're joining on the replay, thanks again. Remember to subscribe to the channel here on YouTube so you get any updates for the live content. Thank you, Enscape, for sponsoring the tip of the week, and Polycam for sponsoring this episode. You guys are amazing. Have a great weekend, and we'll talk to you all soon.
Thank you.